Greetings, A-level students. I'm going to go through a little video explaining what the difference is between a D-block element and transition elements. We're going to also talk about why some D-block elements are not transition elements, and we're going to use electron configuration to support our answer. So let's get the definitions out of the way. A D-block element has its highest energy electron in the D subshell. That's it. So it's an element with its highest energy electron or valence electrons in the D subshell or orbital. That's it. Okay, a transition element. Transition elements form one or more stable ions with partially filled d orbitals. Okay, so taking that further, we're going to now show why some D-block elements are not transition elements, okay? So, scandium and zinc are not transition elements. Let's look at this at the top. We're just going to do it at the top, kind of running out of space. So scandium has electron configuration with 21 electrons that we need to put in, and then zinc has 30 electrons that we need to put in. So here's argon, so that accounts for 18 electrons. So now we're going to go 4s and 3d. So scandium is 4s2, 3d1. In zinc, core electron configuration of argon, then 4s and then 3d. So that's 3d10, 4s2. Okay, so here are the electron configurations, okay? So, tell you what, there might be enough space. So, scandium and zinc are not transition elements, but are D-block elements because the highest energy electrons are in the D subshell. Okay, so just going to move that back up the top because their highest energy electrons are in the D subshell. And we're just going to cement this further, okay? And scandium 3+ has the following electron configuration. So that's a stable ion that scandium forms, has 4s0, 3d0. It has no electrons, it's not partially filled, so we can see that the d orbitals are not partially filled. So, and for scandium 3+, the d orbitals are not partially filled, therefore not a transition metal. TM for transition metal. Let's have a look at zinc. So the stable ion that zinc forms is zinc 2+. So when it forms zinc 2+, the 4s electrons are ionized, so it's 4s0, 3d10, and we can see quite clearly that the d orbitals are fully filled and not partially filled. Therefore not a transition metal. Okay, let's see if we've satisfied the question. Okay, just having a look at my response. I said for the scandium 3+, the d orbitals are not partially filled. Forgot to put in the word filled. What I can do, I can just use one word here, which actually stresses the point better. The d orbitals are empty, therefore not a transition metal. And in zinc 2+, the d orbitals are fully filled, so therefore not a transition metal. And I think that will get us all 6 marks. Okay, thank you for watching. Ta-ta.